is the factor analysis part 5th. In previous video, I was discussing about the stages of the factor analysis, and this is the stage of the factor analysis we call of what stage that is. I'll tell you. This is the stage of 4, which I am discussing. In previous video, I discussed half and the stage of 6. Let's talk about the statistical significance of x square. The implied null hypothesis of structure equation modeling is that the observed sample and structure equation modeling estimation covariance metrics are equal to, meaning the model fit reflect. The x2 value increased as differences residual are found when the comparing the two metrics with the x2 test. We then assess the statistical probabilities that the observed sample and structure equation modeling covariance metrics are actually equal a given population. This probability is a traditional p-value associated with the parameter statistical test. An important difference between the structure equation modeling and other multivariate technique also occur is that statistical test for goodness of fit. For other techniques, we typically look for a smaller p-value less than 0.50 to show that a significant relationship exists. But there, the x2 goodness of fit test is the structure equation modeling. We make interface in a way that is the some ways reflect opposite when the find a p-value of the x2 test for the sample size statistically significant. It indicates that the two covariance metrics are statistically different and the identical problems with the fit. So the structure equation modeling, we took the relatively small x2 value and corresponding large p-value, indicating no statistical significance differences between the two metrics to support the idea that proposed theory fit really. Relatively small x2 values support the proposed theory can model be tested. We should note that the chi-square can also be used when comparing the model, because the difference is chi-square between the two models can be tested for statistical significance. Those it the researcher is expecting differences between the model, for example difference in two model estimated for the male and female, large x2 value would lend support that the model are different. chi Chi-square x2 is the fundamental statistical measurement, that is the structure equation modeling to quantify the differences between the covariance metrics when used of the goodness of fit measurement. The covariance is between the observed and predicted covariance metrics. Yet the actual assessment of the goodness of fit with the x square of value along with the complication by the several factors discussed in the next section to provide the alternative representative on model fit. Researchers developed a number of alternative goodness of fit measurement. The discussion that allow the presence that role the chi-square as well the alternative measurement. Absolute fit indicates a direct measurement how well the model specified by the researcher reproduce the observed data. As such, they provide the most basic assumption how well the researcher theory fit the sample size. They do not explicitly compare the goodness of fit of the specified model to any other model, rather than the model is evaluated dependent or other possible method. X square statistic, the most fundamental absolute fit indicate is the x square statistic. It is the only statistical based structure equation modeling fit measures and is essentially the same as the x square statistical used in across classification analysis between two non-metric measurement. The only crucial discussion, however, is that when used of the goodness of fit measurement, the researcher is looking for the differences between the metrics, that is low x2 values, to support the model of representative of the data. X square goodness of fits has two mathematical properties that are the problematic in In its use of the goodness of fit measurement, first recall that the x square statistic is a mathematical functions of the sample size, and the difference between the observed and estimation covariance matrix as an increase does not the x square value. Even the differences between the matrices are identical. Second, although perhaps not as obvious, the x2 statisticals also is likely to be greater when the number of observed variable increases. Those all of other things, that is just the adding indicators to the model, will cause the x square values to increase and make it more difficult achieve model fit. Although the x square test provide a test of the statistical significance, these mathematical properties present trade-off for the researcher. Although large sample size are often desirable, just as increase is in sample size itself will make it more difficult for those models to achieve a statistical significant goodness of fit. Moreover, as a more indicator are added to be model because of either more construct or better measurement of construct, this will make more difficult in using the chi-square. They should reflect a better fit, not a worse fit, as long they produce valid measurement. Those in some ways, the mathematical properties of the X2 GOF test reduce the fit of the model for things that should be not be determinantal to its overall validity. For this reason, the X2 goodness of fit is the often not used as the sole goodness of fit measurement. Researchers have developed many alternative measurement of fit to correct for the bias against larger sample and increase the model complexity. Several of these goodness of fit indicator are presented next. However, the X2 issues also impact any of these traditional indicate, particularly some of the absolute fit indicate that this said that x2 values for the model does summarize the fit of the model quite well, and with experience the researcher can make educated judgment about the model based on this result. In some of the statistical tests, resulting p-value is less meaningful as the sample size become large of the sample of the observed and variable become large. Goodness of fit index. The goodness of fit was earlier attempted to produce a fit statistical that was less sensitive to sample size. Even though n is not included in the formula, the statistical is still sensitive to sample size due to the effects of the n on sampling distribution. No statistical test is associated with the GFI, and only guidelines to fit. The possible range of GFI values is 0 to 1, with higher values indicated better fit in the past. GFI values of greater than 0.90 typically were considered good. Others argue that 0.95 should be used. Recent development of other fit indicates has led to be decline in use. Root means square error of approximation. One of the most widely used measurement that attempt to correct for the tendency of the x square goodness of fit test statistical to reject model with a large sample of the large number of observation variable is to root measurement error and approximately those the better of representation how well model fit as a population, not just a sample used for estimation. It explicitly traits to correct for the both model complexity a sample size by including each in its computation. Lower value indicate better fit. The question of what is the good value of database, although previous research had sometimes pointed to the cutoff value of zero point 0.5 or zero point 0.8, more recent research points to fact that drawing an absolute cutoff to permits in advisable. An empirical examination of several measurements found that RMSEA was best suited to use in confirmatory or completing the model strategy as the sample become the larger. Larger sample can be considered as a consisting of the more than 500 respondent. One key advantage of the RMSEA is that the confidence interval can be constructed giving the range of the RMSEA value of the given level of the confidence. Those it is unable to the erupt, that is the RMSEA is a between the 0.06 and the 0.08, for example, with 95% confidence. root measurement square residual PRM, and the standardized root mean residual SRMA. As discussed earlier, the error in prediction for each covariance term creates a residual. When covariance are used as input, the residual is stated in terms of covariance, which make them difficult to interpret since they are impacted by the scale of the indicator, but standardized residual are directly comparable. The average SR value is 0, meaning that both positive and negative residual can occur. Thus, the prediction covariance lower than the observed value result in a positive residual, whereas a predicted covariance larger than observed result in a negative residual. A common rule is to carefully synchronize and standardized residual exchange point 0 below the 4.0 or above 4.0 individual. SRS enable a research to spot potential problem with measurement model. Standardized residual are deviation of individual covariance term and do not reflect overall model fit. What is needed is an overall residual value, and two measurements have emerged in this regard fit. The most root means square residual RMR, which is the square root of the mean of the square residual, an average of the residual, yet the PMR has the same problem as residual in a yet related to the scale of the covariances. An alternative statistic is the standardized root means residual SRMR. This standardized value of PMR, that is the average standardized residual, is used for comparing fit across model. Although no statistical threshold level can be established, he researcher can assess the practice significance of the meaning magnitude of SRMR in light of the research objective and the observed or actual covariance or correlation. Lower PMR and SRMR values represent better fit and higher value represent worst fit, which puts the PMR, SRMR and PMSEA into a category of indicates sometimes known as the badness of fit measurement, in which high value of indicative or proof fit. A rule of thumb is that an SRMR over 1 suggests a problem with fit, although there are conditions that make a SRMR inappropriate that are discussed in the later section. Let's talk about the Normed chi-square. The goodness of fit measurement is a sample ratio of x2 to the degree of freedom for a model. Generally, x2 df ratios on the other 3:1 or lesser are associated with better fitting model, except in circumstances with larger sample greater than 750 or other extenuating circumstances such as high degree of model complexity. It is widely used because if it is not provided directly by the software program, it can be calculated easily from the model result. Other absolute indicates. Most structure equation program provide the user with many different fit indicates. In the preceding discussion, we focus more closely on those that are most widely used, but this is by no means an exhaustive list. For more information, the reader can refer to an extended discussion of these measurements on the website, as well as the documentation associated with the specified structure equation modeling program used. Incremental fit in indice. What is this? This is the different from the absolute fit in the indice, in that they assess how well the estimated model fit relatively to some alternative baseline model. The most common baseline model is referred to as the null model. One of the assume all observed variables are uncorrelated. It implies that no model specification could positively improve the model because it contains no multiple factors or relationship between them. This class of fit indicate represent the improvement in fit by the specification or related multivariate construct. Most structure equation modeling program provide multiple incremental fit indicate as standard input. Different program provide different fit statistical. However, so you may not fit all of these in particularly structure equation modeling output. Also, they are sometimes referred to as comparative fit indicates for obvious reasons. Listed below are some of the most widely used incremental fit measurement, but the TLI and CFI are the most widely reported. Normed fit index. The NFI is one of the original incremental fit indices. It is the ratio of the difference in the x square value for the fitted model and null model 1 divided by the x square value for the null model. It ranges between 0 and 1, and the model with perfect fit would produce an NFI of 1. Disadvantage is models that are more complex will necessarily have higher index value and the artificially interflate the estimation of model fit. As a result, it is the used less today in relation to either of the following incremental fit measurement. Let's talk about the Tucker likewise index, that is the TLI. The TLI co-captually similar of the NFI, but variable is that is the actually a comparison of normal chi-square values for the null and specify model, which to some degree take into account another complexity. However, the TLI is not the norm, and those its value can fall below 0 or above. One typically throw the model with good fit have values that approach 1, and model with a higher value suggest a better fit than a model with lower value. Comparative fit index. The comparative fit index is the incremental fit index, that is the improved version of the normal fit index. The CFI is normal, so that value ranging between 0 and 1 with higher value indicating better fit, because the confirmatory fit index has many describable properties including its relative but not complete intensively to model complexity. It is among the most widely used indicator. CFI value above 0.90 are usually associated with the model that fit well. Relatively non centrality index, RNI. The N the RNI also compare the observed fit resulting from the treatment of specify model to that all null model. Like the other incremental fit indicates higher value used to represent the better fit, and the possible value generally range between 0 to 1. NRI lower than the 0.90 are usually not associated with the good fit. Parsimony fit index. The tiered group of indicates is designed specifically to provide information about which model among a set of completing the model is best, considering its fit relatively to its complexity. A parsimony fit measurement is improved either by the better fit or by the similar model. In this case, a simpler model is one with fewer estimated parameters paths. The parsimony ratio is the basic for these measurements, and it calculated as the ratio of degree of the freedom used by the model to the total degree of freedom available. Parsimony fit index are conceptually similar to the notion of and adjusted are two in this sense that they related model fit to model complexity. More complex model are expected to fit the data better, so fit measurement must be relative to model complexity before the comparison between the model can be made. The indicates are not useful in assessing the fit of single model but are quite useful in comparing the fit of two models or more complex than the other. Those use of parsimony fit indicates remains somewhat controversial. Some research argue that a comparison of completing model incremental fit indices provide the similar evidence and that we can take parsimony into the account further in some other way. It is clear to say that the parsimony index can provide useful information in evaluating completing model, but that it should not be rely upon alone. In theory, parsimony indicates are good idea. In practice, they tend to be favor more parsimony model to a large extent. When used to the PNFI is most widely applied parsimony fit index. Adjusted good of the fit index and adjusted goodness of the fit index try to take into the account differentiating the degree of the model complexity. It does so by adjusting GFI by the ratio of the degree of freedom used in a model to the total degree of the freedom available. AGFI penalized more complex model and favors those with a minimum number of free path. AGFI values are typically lower than GFI values inappropriate to model completed. No statistical test is associated with AGFI, only guidelines to fit. As with the GFI, however, the AGFI is less frequently used in the favor of other indicates which are not affected by sample size and model complexity. Parsimony normed fit index, that is PNFI. The PNFI adjusted the normand in the fixed index, we call it NFI, by multiplying its times the PR. Relatively higher value represent relatively better fit, so it can be used in the same way as the NFI, as PNFI take on some of the added characteristic of the incremental fit index relatively to absolute fit index in addition to favor the less complex model. Once again, the value of the PNFI are meant to be used in comparing one model to another with the higher PNFI value being most supported with the reflected of the criteria captured by this index. Problem associated with the using the fit index. Ultimately, fit indices are used to be established by acceptability on any structure equation model. Probably, no structure equation model topic is more dedicated than what constitute an adequately or good fit. The expanding the collection of fit indicates and the lack of consistent guideline can tempt the research to pick and choose an index that provides the best fit evidence in one specified analysis and different index in another analysis. Research is faced with two basic questions in selecting a measurement model fit. What are the best fit indicates to objectively reflect a model fit? What are the objective cutoff value suggestion good model fit for a given fit index? Unfortunately, the answer to both questions is neither simple nor straightforward. Some researchers equate the search for answers to these questions with the mythical golden friends, the search for the fountain of youth, the quest for absolute truth and beauty. Indeed, many problems are associated with the pursuit of good faith. Following is a brief summary of the major issues found in the various fit indices. Problems with the X-square test. Perhaps the most clear and convincing evidence that the model fit is adequate would be a x2 value with a p-value indicated no significant difference between the observed and estimated covariance matrix. For example, if a researcher used an error rate of 5%, then p-value greater than 0.05 would suggesting that the researcher model capably reproduce the observed variable covariance matrix, a good model fit. But as we have discussed earlier, so many factor impacts by x square significant test that particularly any result can be questioned. Does a non-significant x square value always enable a researcher to say case close we have good fit? Not quite. Very simple. Model with a small sample have a bias towards a non-significant x square even though they do not meet other standard or validity or appropriateness. Likewise, there are inherent penalties in the x square for the larger sample size and larger number of indicator variable. The result is that typically model today are more complex and have sample size that make the x square significant test less useful as a goodness of fit measurement that always separate good for poor model. Those no matter what the x square result, the researcher should always complement if with the other goodness of fit indicate, but just as important the x square value itself and the model degree of freedom should always be reported. Cutoff values for fit in indices, the magic 0.93 or is that 0.95. Although we need to complete the x2 with additional fit index, one question still remain matter what index is chosen. What is the appropriate cutoff value for the index? For most of the uh, fit statistical accepting model, producing the value of 0.90 becomes standard practice. In the early 1990s, however, the case was made that 0.90 was too low and could lead to false mode is being accepted, and by the end of the decade 0.90 had become the standard for indices such as the TLI and CFI in journal. 0.95 somehow become the magic number indicating good fit in model. Yet research has challenged the use of single cutoff value for GOF indices, including tested that a series of additional factors can affect the index value associated with acceptable fit. First, research using stimulated data for which the actual fit is known provides counterargument to these cutoff value and does not support 0.90 as a generally acceptable thumb. It demonstrates that as the time even an incremental goodness of fit indicate above 9 would still be associated with the severalty misspecified model. This suggests that cutoff value of should be higher than 0.90. Second, research continue to support the notion that model complexity unduly affected goodness of fit in indices even with the sometime as simple as just more indicators per construct. Finally, the true underlying distribution of data can influence fit indices, in particular as data become less appropriate for the particular estimation technique. Select the ability to fit indices to accurately reflect misspecification can vary. This issue seems to affect the incremental fit index more than absolute fit index. What has become clear is that no single magic value always distinguish good models from bad models. Goodness of fit must be interpreted in light of the characteristic of the research. It is estimated to compare these issues in structure equation modeling to the journal lack of the concern to establish a magic R2 Number of multiple regression, that is if a magic minimum R2 value of 0.5 had ever been imposed, it would be just an arbitrary limit that would exclude it potentially meaningful research. So we should be quotation is adoption on size first all standard. It is simply not practical to apply a single set of cutoff rules that apply for structure equation modeling for any type unacceptable model specification to achieve fit. Researchers sometimes test theory and sometimes pursue a goodness fit. The desire to achieve goodness fit should never compromise the theory being tested. Yet, in practice, the pursuit of increasingly model fit can lead to several poor practices in model specification. In each of the following instances, a researcher may be able to increase fit but only in a manner that compromise the theory test. Although each of these actions may be required in very specified instances, they should be avoided whenever possible because each has the potential to unduly limit the ability to structure equation modeling. Provide a true set of model for the researcher learn not only from the theory that is confirmed but from the areas where theoretically expectations are not confirmed. One area of poorly practice involves the number of items per construct. A common mistake is to reduce the number of items per construct to only 2 or 3. Although doing so many improve model fit by reducing the total number of indicators and even improve the reliability of the construct, it very likely diminish its theoretical domain and ultimately its validity. The concept of the multiple measurement was to include as wide range of the possible of items that could measure the construct, not limit it to very small subset of these items. An ever more extreme action is to be used a single item to represent a construct necessitating an arbitrary specification of measurement error. Here the researchers circumvent the objective of the measurement model by providing the value of the indicator. Single item should only be used when the construct truly is and can be measured by a single item, that is the binary variable such as purchases, no purchases, succeed, fail or yes or no. Finally, a test of the measurement model should be the performed with the fully set of item. The parceling of item where the null set of the indicator variable, that is the 15 indicators and construct, is parcel into the smaller number of composition indicator. For example, 3 composite of 5 items can reduce model complexity. Would may observe the qualities of the individual items. Those parceling of item is performed is should be the employed after the entire set has been evaluated. Another poor practice is to assess the measurement model fit through the separate analysis for each construct instead of one analysis for the entire model. This is an inappropriate use of the goodness of fit indicates which are designed for testing the entire model, not a single construct time. The result is not only an incomplete test of the overall model but a bias towards the conforming model because it is easier for single construct to each meet the fit of index than it is for the entire set of the achieve acceptable fit. Moreover, test or discriminant validity and potent it item across the loading are impossible unless all of the constructs are tested collectively. Finally, most model fit indices can be improved by the reducing the sample size. This approach is, although improving the model fit, obviously runs counter the needed for use as large a sample as possible of feasible to ensure representativeness and generalizability. Moreover, it increases the chances for encountering statistical problem with the model convergence, less accurate parameters, estimates, and lower statistical power. Awareness of the problem resulting the first these section does not mean that one of them might not be necessary to address a particular model specification or to be helpful diagnostically. In building a model, still improvement in fit is not an appropriate justification for any of these steps. Always remember that these procedure can in refer with the overall test of the measurement model and those the measurement theory remain tested until the measurement variable are included in a single test. Guideline for establishing acceptable and unacceptable fit. A simple rule for index the distinguished good model from poor model across all situations cannot be offered. It amount of overemphasized that these are guidelines for using, not rule that guarantee correct model. Those no specific value on any index can separate model into the acceptable and unacceptable fit. However, several journal guidelines used together can assist the determining the acceptable of fit for a given model. Use multiple indices of the differing type. Typically, using the 3 to 4 fit indices provides the adequate evidence of the model fit. Current research suggests a fairly common set of the indices perform adequately across a wide range of situations, and the researcher need not report of goodness of fit in the indices because they are redundant. However, the researcher should support at least one incremental indice and one absolute indice in addition to the x square value and the association degrees of the freedom, because using the single goodness of fit indice even with a relatively higher cutoff value is no better than simply using the x square goodness of fit test along those the reported then x square value and degree of freedom. The CFI and TLI and the RMSEA will usually provide the sufficient unique information to elevate a model. The SRMR can replace the RMSEA to also the represent badness of fit, whereas the another represent the goodness of fit. When the comparing the model of varying the complexity, the researcher may also wish to add to PNFI. Adjust the index cutoff value based on the model characteristic. Table 4 provides some guideline for using fit indice the different situation. The guidelines are based on primarily on the situation research that consider a different sample size, model complexity, and this is the table for characteristic of the difference fit indice and demonstrating the goodness of it across the difference model situation. Here is the m less than 12, 12 less than m, and m less than 3, m greater than 30. So x square significant p value of subjected, significant p value even with good of it, significant p value of expected. This is the table which is showing you the and which is in demonstrating you goodness of it and across the goodness of model. And number of observed variable and apply of the number of observed p when applying the CFA confirmatory factor analysis a multiple group of the same item. Degree of the error model specification of examining how accurately various fit indices perform. One key points across the result of the simple model and the smaller sample should be subjected to more strict evaluating than our more complex model with the larger sample. Likewise, more complex model with the smaller sample the require the sample what less strict criteria for evaluating with the multiple fit indices. For example, based on sample of 100 respondent and our for construct model with only 12 total indicator variable, variance of the good fit would include an insignificant x square value of the CFI of at least 0.797 and the RMSEA 0.08 or lower. It is extremely unrealistic, however, to apply the same criteria to an 8 construct model with 50 indicator variable tested with a sample of the 2000 respondent. It is important to remember that table 4 is provide more to give the researcher an idea of the how fit indices can be used and to suggest the absolute rule for the standard separating good and bad fit. Moreover, it is worth repeating that even a model with a good fit must still meet to another criteria widely Ampere models whe- whenever possible. Although it is difficult to determine absolutely when the model is good or bad, it is much easier to determine that one model is better than another. The indicate in table 4 perform well is distinguish the relatively superiority of the one model compared to another. A CFI of 0.95 for instance indicates truly better fit than the similar model with the CFI of the 0.85. A more in depth discussion of the completing model is described in stage 6. The pursuit of the better fit at the expense of the testing a true model is not a good trade-off. Many model specification can influence model fit, so the researcher should be sure that all model specification should be done to best approximately the theory to be tested rather than the hopefully increased model fit. Let's talk about the stage 5. Specifying the structure model. Specifying the measurement of model, that is the assigning the indicator variables to the construct and should be represent. It is a criteria step of developing a structure equation model. This activity is accomplished in a stage 2. Stage 5 involve the specification of the structure model by assigning the relationship from one construct to another based on the respondent and theoretical model. Structure model specification focus on the using the dependence relationship type from figure 1c to represent the structure equation of the researcher model. In other words, what dependence relationship exists among the construct. Each hypothesis represents the specified relationship that must be specified. Specify the measurement model, that is the assign the indicator valuable to the construct that should be represented. It is a critical step in developing the structure equation modeling, that is the completion in the stage 2. Stage 3 involve the specification the structure model by assigning ratio step from one construct to another based on the proposed theoretical model. Structure model specification focused to another based on the proposed theoretical model. Structure model specification focused on adding the single headed directional arrows to represent structure and hypothesis is the researcher is model. In other words, the researcher identified that the dependent relationship that hypothesized to exist among the construct. Each hypothesis represents a specified relationship which must be specified be written in job search model. And from earlier in the chapter we have specified the fully measurement model as shown in the figure 9 where there were no structured relationship among the construct. All the construct were considered exogenous and the correlated. This is also known as the confirmatory factor analysis model. In specifying structure model, the researcher now carefully selected that are believed to be the key factor that influence job search from their experience and judgment. The Bhatt research team believe that is a strong reason so supreme that the perception of the supervisor work environment and the co-worker affected job satisfaction, which in turn to affect the job search. Based on the theory, research team proposed the hypothesis structure relationship. The first supervision perception are positively related to job satisfaction. As to work environment perception are positively related to the customer. Co-worker perception are positively related to the customer. Shared job satisfaction is negatively related to the search. The structure relationship are shown in the figure 10. H1 is specified with the arrows connecting the supervision and the job satisfaction. In a similar H2, S3 and H4 are the specify the single headed arrows showing the dependence relationship between the construct and represent the structure part of the model. The construct display the specified measurement structure linked of the variable that would be already being tested to the confirmatory factor analysis state. Any relationship among the exogenous construct and encountered with the correlation relationship co-worker co-head arrows. Those the three relationship among the two exogenous construct are specified just as they were in the measurement model. Another way to view the structure model is that constraint can be added to the measurement model. That is, the specified structure path replace the correlation between the construct for each hypothesis. Relationship with the exception of the correlational relationship among the exogenous construct. No path is drawn between two constructs unless a direct dependence relationship is a hypothesis. Thus, all the relationships not shown in the structure model are constrained to be equal to 0. Although the focus is this stage is one, the structure model estimate of the structure equation model required that the measurement specification be included as well. In this way, the path diagram represent both the measurement and structure path of the structure equation in one overall model. Those the path structure equation modeling overview, supervision, work environment, co-worker, job satisfaction, and job search. Supervision impact on the job search. It is also the job set link to the job satisfaction. It is also the link or the co-worker. All variable intercorrelated to each other. Diagram in the figure 10 shown as the only the complete set of the construct and indicate in the measurement model, but the impose of the structure relationship among the construct. The model is now ready to estimation. They become the test of overall theory, the including the both the measurement relationship of the indicator to the construct as well as the hypothesis the structure equation modeling construct. These are the supervision, co-work environment, co-work and job satisfaction. Let's talk about the stage 6, and this is the last stage of the structure equation modeling. Assessing the structure model validity. The first stage involves the efforts to test the validity to the structure model and its corresponding hypothesis. Theoretically relationship, that is the H1 H4 in our simple example. Realized that if the measurement model has not survived, it is the reliability and validity in the stage 4. Stage 5 and 6 cannot be performed. We would have the reached a stopping point and must achieve the acceptable result in assessing the measurement model before the proceeding. If you do not have achieved acceptable fit to the measurement model, fit will not improve when the structure relationship are specified. Only when the measurement model is validated and achieve the acceptable model fit can be turned on attention to the test of the structure relationship. Two key differences arise in the testing the fit of the structure model relatively to a measurement model. First, even though acceptable overall model fit must be established, alternative or completing models are encouraged to support a model superiority. Second, the particular emphasis is placed on the estimated parameter for the structure relationship become the wide the direct empirical evidence relating to the hypothesis relationship depreciated the structure model goodness of fit. The proposal of estimated the structure model validity follows the journal guideline and outline in the stage 4. The observed data are still represented by the observed sample. Covariance metric, it does not only should not change. However, a new structure equation modeling covariance matrix is computed and it is the different from that from the measurement model. This is different is a result of the structure relationship in the structure model. Remember that is the measurement model assume all constructs are correlated with one another. Correlational relationship, yet in a structure model that is relationship between the some construct are assumed to be zero. Therefore, for almost all conventional structure equation model, the x2 goodness of fit for the measurement model will be less than x2 goodness of fit of the structure model. The overall fit can be assessed using the same criteria as the measurement model, using the x2 value for the structural model at least of the absolute index and one incremental index. These measurements establish the validity of the structure model. but comparison between the overall fit should be also be made with the measurement model. Generally, the closer the structure model comes to the measurement model, the better the structure model fit become. The measurement model fit provide an upper bound of the goodness of fit of the conventional structure model. Competitive fi. Earlier, a competing model assessment we discussed as one approach to structure equation modeling. The primary objective is to ensure that the proposed model not only has acceptable model fit but that is perform better than some alternative model. If not, the alternative theoretical model is supported. Comparing model can be accomplished by the assessing the different in incremental or parsimony fit in index along with the reference in x2 GOF values for each model. Let's talk about the comparing and nested models. A powerful test of alternative model is the compare model of similar complexity yet representing the varying the theoretical relationship. A common approach is through the nested model where the model is nested within the another model if it contains the same number of variable and can be found with the another model by the altering the relationship such as the either adding the deleting path. Generally competing nested structure equation model are compared based on the chi-square difference statistic. The x square value the sum baseline model b is the subtracted from the x2 value of the lesser constraint. Alternative nested from similarity the difference in the degree of the freedom is found which one less degree of the freedom for each additional path that is the estimated. The following equation is used to for the computation. Because the difference of two x2 value is the itself x2 distribution, we can test the statistical significance given the delta x2 difference values and the difference degree of the freedom. For example, a model with 1 degree of freedom difference a delta df is equal to 1 meaning of additional path of the model. Better would be significant of 0.05 level. The researcher would conclude that the model with one additional path provides a better fit based on the significant reduction of the x2. Goodness of fit nested model can also be form of the deleting a path with the same process followed the calculating difference in the x2 and the degree of the freedom. An example of the nested model of the figure 10 might be the addition of the structure path from the supervision and construct directly of the job search. Construct this is added of the reduce of the degree of freedom by 1. The new model would be the estimated at the x2 calculating if the larger than the 3.84, then the researcher would conclude that the alternative model was the significantly fit before the path is added. However, there must be theoretically support of the new relationship. Com- compromise comparison to the measurement model. Let's talk about its measurement model comparison. Users should know how to perform this chi-square difference test because the structure equation modeling program is not likely to provide the extremely the test of needed is every case. One useful comparison of the model is between the confirmatory factor analysis and the structure model fit. The structure model is composed of theoretical networks of relationship among the construct to the conventional confirmatory factor analysis. All constructs are assumed to be related to all other the true cuts. As discussed earlier, a structure model will generally specify the fewer relationship among the construct because not every construct will be hypothesized to have the direct relationship with every other construct. In the same sense, structure model is more contained than a measurement model because more relationship are the fixed or to zero and not allowed to be estimated. A way to think that it is the structure model is a form of measurement model by adding the concentrate. Adding the concentrate cannot reduce the chi-square value at the first if the relationship between the construct true is zero, and the research state that relationship to 0 is not specified. It is the structure model that actually chi square value will be unchanged. By the adding the constraint, which is the following construct, truly are the relatively by the adding the relationship of the model should reduce the chi square value of keep it the same. Just as described adding the deletion path, adding the path means the constraint has been relaxed, and deleting a path means constraint has been added. Change the degree of freedom accordingly. Adding one constraint means and the chi square difference test will have 1 degree of freedom. Additional 2 means the test will have the 2 degree of freedom, and the fourth with means the unremittent model and the structural model have approximately the same chi square value. This means the overall x2 goodness of it for the job search complete measurement mode can be compared to the two models. The test would be the ADF3 because three relationship that would be estimate of the confirmatory factor analysis. Measurement test model are considered the zero. That is the structure model specify non direct relationship between the from the exogenous construct and supervision environmental co-working to test with 3 degrees. By not allowing these three direction inter relationship did not significant worst fit and significant x2 first between the measurement model and structure model would generally provide the support evidence and the proposed of the theoretical model equivalent model. This is the thumb 2 3 and then the summary. Now we have the read about only the very few things. The first is the equivalent model, that is good fit statistical do not have the theory is the best way to examine the observed example covariance matrix. As the described earlier, any number of equivalent model exist for any proposed model and they will produce the same estimation covariance matrix. Therefore, any given model, even the good fit, is one potential elimination of the most significant equally well. This means the good empirical fit does not prove that the a given model is only the true structure of the favorable fit structure of the highly described that many alternative model can provide an evaluating fit. These issues further reinforce the need for building measurement model based on solid theory. More complex model may have a quite large number of equivalent model, yet it is quite possible that many of all make little sense give the conceptual nature of the construct involved. Those in the end of empirical result provide the some evidence of the validity, but the researcher must provide the theoretical evidence of that it is equal to important to validation of model. Testing structure relationship. Good model fit all the insufficient to support the proposed structure model theory. The researcher also must examine the individual parameter estimation that represent of the each specified hypothesis. A theoretical model is considered valid to the extent to which the parameters are estimated statistically significant and the parasitic direction, that is they are greater than 0, a positive relationship less than 0 for a negative relationship. Narratively, the characteristic of non-trivial, the characteristic of should be checked. Checking the complete standardized, adding the estimation, the guideline here is the same as to the other multivariate technique. Therefore, the structure equation modeling shown that figure 10 consider acceptable only when it demonstrates acceptable model fit and P estimate researcher. Each of the four hypotheses are the significant and the predicted of the action. The researcher can also the examine the variance and examination for the underground construct, and these are the R square performed in the multiple regression rule thumb 3. And after that we have this summary of this chapter, which I will make the particular different videos about the summary. Previously I was discussed about the Thomas Edison. I also was the discussed I discussed about the researcher. So I will provide you some link on this video if you want to know and read about the researcher. So you can go and read, you can listen, whatever you want according to your convenient, you can gain your knowledge. Let's come back to the topic. Structure equation modeling 4 or 6. As model become the more complex, likelihood an alternative model with equivalent fit as multiple indicates should be the as the mobile goodness should indicate the x square value of the associated of index is the these are the values which they model with equivalent fit inch. No signal magic value of the fit index separate good from poor models, and it is practice of the applying the single of the rule and measurement of the model and the structure equation modeling of any type. The quality of the dependent heavily model characteristic including the sample size and model complexity. The sample model with a small sample behold the strike and standard, the even the insignificant more complex model with the larger sample should not be held to the same strike standard. And so when the sample are large and the model are contain the large number of measurement values and parameter estimation cutoff values of 0.95 on the key the goodness of fit measurement and unrealistic. Next video I will talk about the summary of structure equation modeling. I hope this concept is clear for everyone.